All right, everyone. Welcome to this month's AI in Construction. Today, I'm super excited to have Burcin Kaplanoglu from Oracle. He's been running their innovation lab for a couple of years. It just has an amazing view of construction technology generally, but artificial intelligence specifically. They've been leading a bunch of different interesting things. On my podcast, actually had one of the architects of the construction intelligence cloud, something we'll be talking about today, and the year and a half since that interview, it's been really come to fruition. So with that, I'm going to welcome Burcin. Welcome to the webinar. I don't know if you want to go to the next one and maybe introduce yourself a little bit and what we're up to.
Absolutely. Hi, everyone. Thanks for joining, and it's great to be here. As you mentioned, I have been leading some work at Oracle related to development of the Oracle Industry Lab. We actually have 3 locations globally. It's built as a test bed where we trial and test technologies. And the discussion that we're going to have today and the examples I'm going to show, I have to give credit to a very large team, by the way. So it takes a lot of people to actually work on these. So some of them will be what you're going to see today. Some of them are actually commercially available. Some of them are prototypes. So some going to provide some solid examples of what actually has been done available and what actually is in the work. So I'm excited to share that.
Awesome. So I'll give a little more intro. So today, folks, we're going to go through kind of 3 buckets. Machine learning and deep learning are a little more mature than some of the other things that we'll see, where they've really been working at it for a little while. I'm going to moderate. A lot of this is going to be Burcin talking about concrete things they're really doing, either because customers are using them and you'll see some cool results that people have already been able to achieve, but also things that are being tested as well. So the focus always of these webinars is what are people really doing, not just what are they talking about. And I really am excited that again, Oracle got at this early. Oracle as a company has been a leader in AI anyway, and you're probably hearing some of that in the news. But specifically to construction, they got ahead of this and thought about something that I really liked. And I'm going to pull this from the webinar, or sorry, podcast I did a year ago, where rather than worry about whether your data is going to go somewhere else, what Oracle will do is provide a kernel model that can then learn on your data, which is really exciting because it basically takes away some of the concern about data going anywhere else or you contributing to someone else's enterprise value, something that's come up a few times. But also it means that you still benefit from all of their knowledge and experience without this concern about where data goes and what it turns into. So I always thought that was a really exciting way to do things. And frankly, it's something only a company of Oracle scale can do. It'd be hard for a startup to be able to get that level of data to provide to you as a starting point. So with that, I think, Burcin, if you don't mind taking it away with machine learning and deep learning, do you mind just starting with a little background? I kind of gave a starter there, but talk a little bit, if you don't mind. When you say machine learning and deep learning, what do you guys mean? And just a little bit of your approach.
Well, you did a great intro, so let's start with that. In the machine learning space, the examples I'm going to provide, next one will be like the first one I'm going to provide is scheduling, no surprise to audience, because that is, one of our core products. We did build seed models, so when customers actually start using the scheduling prediction, they actually do get that seed model. But what happens is they actually do retrain the model based on their data. And the key here is, I'm going to say this, I think, several times. So this is my first time. You do not need to be a data scientist. So the model is trained, but literally you just click some boxes and it trains itself. And then you will also have the seed model that is coming from us and the trained model that is coming from, that is the one that's actually trained with your data. And you can choose to use whichever model. Literally, it's like a list, and you say, I want to use the seed model, I want to use this, I want to use that. And the key differentiators, as you said, is we are providing the seed model when it comes to scheduling. Let me go to that slide so you will actually see physically, visually. Okay, here we go. So like it will say 74% likelihood this project is going to delay by 15 days, and it's the 20% of the duration. And it actually gives you the reason why. So So these predictions are actually, customer can choose whether to based on our seed models or their own data.
And this is just to clarify, this is based on, or this is looking at schedules, right? You're taking in schedule
Correct.
data for this one. I think that when I set this one up, I may have left that word out. So you guys are ingesting schedules and training there based on your seed model to be able to do this sort of prediction.
Yes, and as you see here, it even says like 10% likely of this many days, 75% of 15 days, 90%, over 2 days. So it's actually even giving you kind of a scale of this. And what else it does, it also gives you a benchmark. So like projects that are actually similar, it's telling you the goal here is still learning from the past, like past projects, how much they delayed, what the impacts were. You'll be able to get into that level of detail. And what you're seeing right now, for the audience sake, is what you're seeing now is commercially available. So we are
And
actually, having this sit on top of our several products. It's called Construction Intelligence Cloud, and it has different modules where it goes and grabs data from, multiple of our products and actually, makes predictions.
and when it makes the predictions, just to make sure I'm clear, it'll tell you not just that I think that you've got a risk of some delays. Will it point out what's going on that drives that? So I
Yes.
think this thing might be what slows you down, or we found this sort of thing usually is
Yes.
underestimated.
Absolutely. And look, some other examples that I'm gonna give, I'm gonna go to the next one. Like this is another module, is called Litigation Risk Overview. Well, the team actually built a model based on litigation. And the way it works is it's similar to how, like today, if you use any like email, right? Something's actually read through your emails. It now even makes recommendations to you. It says, hey, you want to use this word, or do you want to reply to that person? Same logic. There's a model built, and I believe we patented it, where the model looks at certain language that's used in communication. And if you think about the project, I'm sure the audience knows this, you have an owner, general contractor, many subcontractors. So some of the communications could happen at, 3 levels below, eventually could turn into a major risk, right? So it is actually highlighting some of those things based on the communications, other issues, design issues. Look, on the right in this example, it says risk identified by top mail types, right? So request, and this is not the request for information process. This is in the mail, somebody's actually asking, some information, or transmittals or design queries, sketch, whatever the issue is. So it is picking those key things and highlighting, and then the user can actually go and look at them and say, okay, this is a risk. It's actually like a thumbs up and camera, sorry, thumbs up, thumbs down. Sorry. Like you can say, yeah, I agree with this. I don't agree with this. That actually helps to get the model, adjusted.
There was a question from Alex in the audience about what regions these are available for. Now we're talking about more than one thing. We just talked about schedule. Now we're talking about something that's a little more litigation focused. Where are these available?
When
And
you say
presumably it's a global question. It's not
it
what
is a
parts of
global, I mean,
America.
this is
Yeah,
a
yeah.
global tool. So
Okay,
it's a global tool. Yes.
got
And
it.
let me clarify one thing. So let's say you made a recommendation. You said, yep, litigation, that's not a risk. This is a risk. You make some decisions. It doesn't go automatically updated. It's actually the customer decides when it needs to go and update it itself. Like you have a way to say, yeah, I've done enough of this, go update the model. There are specific things that are designed in a way, like some of the stuff is fully automated, updates like, from the feedback, and some are actually allowing the end user to make those decisions. It's based on the feedback we got. Like next example I'm going to talk about is RFIs. So this is actually looking at requests for information. It's telling you the reasons. You can go deeper into it. So let's say it predicted and say, because of this RFI, this is going to delay by 10 days. And then later it delayed by 7. It automatically updates. The model says, oh, this issue was 7, not 10. So like there are certain things we actually made decisions throughout the design of this is based on customer feedback, and people want to manage things differently. And that's how it's working.
And this gets back to what you were saying before. You don't need to be a data scientist to use this. You guys have abstracted some of what a data scientist would do for you, it sounds like. Created
Absolutely.
controls and tools that an operator and a PM or, anyway, someone who's focused on the job will still be able to work with and understand.
Absolutely. And the one that I want to say is I'm actually will be able to give some solid outcomes is this one really safety. So this is looking at it's automating some reporting, right? So it's doing some reporting of what the incidents are, what happened on a job site. It's using vision. Also, I would say this is a really good example of we're not just leveraging one technology. I know I, we group this under machine learning, but it's more than that. It's machine learning, it's computer vision, it's using, you know, different insights, but it can actually give you a weekly risk summary. And let me walk through the process. So if you look at this on the left, it says this week's risk rank, and you see Voice Tower is, minus 11 points change. That is a trigger. So that tells you that you should, it also will give you the reason why and why it's predicting what is more likely to anything to happen on that project. And as you see on the right, like priorities and actions. And most likely what we have seen is when this is recognized, they actually send a team to the project to check out what's going on, because this is like a trigger based on the data it collected in the week before. These are the things. And I've talked to the person who actually developed this, which is Josh Kanner and the team. So some of you might know Josh. And he told me that it's not just looking at images, it is looking at 150 data points, and it is looking at weather, it's looking at other things. So it is using all these factors to make a prediction of what it could be.
Well, hang on.
Now,
Can we just stick for a second before we talk about how amazing
sure.
it was? When you
Yeah.
say images, what inputs are they using? Is this people taking photos, or is this cameras on the job site, like security camera type things? Where's it getting its inputs?
People's taking photos and it is assessing the imagery. I believe there's also a way to tie to cameras, but I need to validate that. But predominantly, to my knowledge, it is actually people taking images on the job site. Like it can recognize a lot of things on a job site, from how the job site is organized. Josh and I talked about this many times. Like in my past work life, I also had worked on something like one of the things I found in my past life working in the industry was there was a relationship between um, the whatever you call it, site tidiness, cleanliness, organization, and the incidents. Like if you see and the site is really well organized, things are stored in a certain way. My previous employer, I worked for 16, 17 years. I worked for Lendlease. We were able to prove there's a relationship with how clean the site is and the safety incidents. And I think to my discussions with Josh Kanner, they come to similar conclusions to it is showing you a pattern of people, certain behavior, certain things actually will be a trigger for that.
And are there kernel models or seed models for this as well? I know this is a bit of an addition that didn't grow up the same way as some of the other tools, but does this fundamentally work some of the same way, that there's a kind of I keep calling it kernel, but a seed model that then gets trained on the company's data?
Yes, yes. I mean, look, this has the base model and it changes as you're evolving. Yes.
That's great. And again, it's just to drill in here. Same as the other ones, the whole point of that is your data as a customer isn't going to, especially safety data, which obviously people are sensitive about. I always thought that was one of the coolest things that you guys did, is that your data doesn't go to train for other people's benefits, right? Is that it's going to help you, but it doesn't go anywhere other than your instance.
Absolutely. Absolutely. And look, eventually, where does this land? So these are reports that are published publicly. It is showing significant amount of dollar savings, but more importantly, it's actually showing reduction in incident rate and worker comp rate and total recordable incidents rate. So we know that we have done a significant improvement on job site safety in last 2 to 3 decades. But the last 4 or 5 years is showing, it's kind of flatlined. We need to have different tools and techniques to actually improve them. And we are seeing that having these kinds of predictive models and tools to actually do that is really helping. So what you've seen, Q, and everyone who's actually listening and watching this, everything I shared so far is commercially available. So that's, I think, very important. The stuff that I'm going to talk about when I go to vision and Gen AI, I'm going to go more into the prototypes that I'm actually working on and the technologies that we actually tested.
And let's stop for a sec. And if there are any questions from folks that are listening, let me know. Henry has a question. If AI is scraping emails, do you require specific conventions and ground rules regarding naming, classifications of emails, and so on? Basically, I mean, it's kind of like a data dictionary question. Is people decide to call the same thing different things. How do you guys handle that?
The model is trained on, like, model knows. Let me say this. When I say I actually, so when I say the word the mail, right? So this is the mail communication that happens in ACANX. So there is a part in ACANX where project communication happens. It's not an email, by the way. It's a different setup. And the model is based on different language that's used. So like we have many ways to call it a drywall, as an example, right? You can drywall, blueboard, whatever you call it. So the team actually have worked on, and that's a challenge. Look, that's a great question. Like region to region, location to location, you can use different names, different things. It's hard to classify these things, but they were able to find some commonality based on, litigation documentation and, based on where you are. So,
But also,
unfortunately, for US, we all know it's a pretty litigious environment, right? So I don't think there's lack of data and public information about what that, it would be.
Also, though, that is some of what deep learning is very good at, is being able
Yes.
to handle different ways of saying the same thing. You obviously want to make sure it's been trained on what those may be, but it's pretty resilient to people's varying ways of saying the same thing. So it sounds like in the US for sure you got plenty of training data, but also again that's the point of using deep learning instead of just keyword search, is that it's a little bit more resilient to the varying ways people can talk.
Yes. And like my previous life, again, this is from my Londonese days, we actually were able to identify where a schedule is built, which region is built based on the language. And it was all NLP. Like you could run an NLP and it builds this and says, okay, these are, this is the language they use. And even from like schedulers in the north versus schedulers in the south, even what level of detail that people provide and what they're used to, like what level of task detail. I mean, there is a lot, like, because it's humans, right? Human has, I always give this example. If you take 10 schedulers and give them a schedule, I bet you they're all going to build it differently. Like there are some certain rules that probably will be similar, but from the direction where they start from, how they go from activities, what level of detail they'll provide. Is it a task? Is it an activity? Is it even like more detail? This is all, when we got as humans involved, like you said, deep learning is a good place to actually capture that because we have massive variations.
That speaks actually to one of the things, just while we're here. Anytime you're using AI, whether it's deep learning or generative AI, but this is very true with deep learning, it's going to give you a percentage likelihood that it's correctly identified some, whatever it is. If it's a dog and you've trained it on 10 million dogs, it's still going to give you a probability, which may be very high, it may be 99%. But humans do that too. We just don't know it. But the point I'm making is that it's going to cover some percentage of the world, and there's always a corner case. There's always an edge case that you just didn't know about. And the key thing is that it's doing things no other software could do, and you probably wouldn't have the money to hire a human to do. So if it's getting you 80 or 90% right, that's enormously better than the starting point, and a better comparison than does it do everything. Because I think sometimes when we think about Excel and other software, every single time I do an addition, it better get it right. We're not used to probabilities in software. So that's one of the learnings that we're all getting used to in AI, is that it's really powerful and it can handle a messy world, but some of its outputs as a result aren't as perfect as they would be if we lined everything up in perfect ducks, perfect rows, and made it, into a spreadsheet.
Well, you opened up Pandora's box, my friend. So when we look at and look, I'm an engineer, so educated myself in engineering, all that stuff, and we want we look at things and we say, oh, it needs to be 99.999% accurate. The reality is it does not need to be. Not every use case needs to be that accurate. And there's also always a probability of something. There's a probability of something always in our world. I love what you said. In our head, we also know that too. Like when we're looking at things, we go like, yeah, we know what likelihood that thing to happen to us, or we think about risks, like or even like I'm signing a contract and there are clauses in there which I had to agree, but then I'm doing this knowing that which is not really likely. Like so, like there are decisions we make in life, and now what's happening is the machines actually can make those decisions. Like they're actually making those decisions, and not every use case needs to be that accurate. Um, if you think about it, if something gives you like in safety observations, right? So if it's something is giving you 80%, 90% accurate, it's better than having something giving you 0%. Like if you think about that perspective, right? Because having those tools, which you actually never were able to use or have in the past, is the big change. But we as humans are not going anywhere. We're always going to be part of this because that edge case, which is 10%, is the one that we need to make a decision on.
And the other thing I would add is the question always comes up in AI, where what's the role of the human? Is this going to take my job? And what we just said is these tools are giving you unprecedented inputs, but ultimately it's up to the project team to make the final decision. And they're giving you strong recommendations. They're telling you this is true, this is a risk, just arming you with way better information than you've ever had before. But at the end of the day, they're not replacing the project team. They're just giving them incredible visibility into the project, but also no human would be able to say, hey, I've just looked at 10,000 projects, whatever the number is, 100 projects, and
Yeah.
I've quantitatively looked at those and said, here's what I've learned from those 100 projects. The best you're going to do is I've done 10, or 20 or whatever the number is, and I roughly kind of remember that was the time when I got my toe got stubbed really badly. You know what I mean? Like
Yes.
you're not going to remember anywhere near the same level of sophistication as an AI would. You will remember those moments that were awful, but there's hopefully not too many of those. So it really gives you a much better lens into the past than humans are really built for.
So I will another personal example. Now that you said that, I thought about this. 25 years ago, when I started in the industry, worked on a high-rise building in downtown Chicago. Had a structural engineer that I work with. He awarded work for steel. By the way, he has done similar scope of work on three other high rises in the let's say the last decade. Okay, so he had a Word document of things he has learned. So let's say there's a problem, right? He learned that let's say he deals with a problem. It takes like a month to deal with. The next thing he would do is he'll open up his Word document and he will write a language to protect himself in the future. That's not for the actual work that he's doing. It's for the future work that he's gonna go and he's gonna embed that language in the contract because that's what he's learning. Like that's how he kept his experiences. Basically said, okay, I dealt with this. It was an end of a project also. Like he was actually gradually doing this as the project progresses. That list was very long, by the way. Like sometimes you go like, what is this? But he had these many bullets that he kept, and that's his knowledge base. Like next project that he moved, he looked if they're applicable or if anything related to it. Also reminded him what the issues were that he had to face with. So he would literally protect himself, based on the past. Now, take the same concept, imagine as machine learning, right? Apply to the fact that you learn all the stuff. There's so many things we learned. And the example I've given, hey, I predicted it's going to be 10-day delay. Now it's 7-day. Let me update the model, right? So the intention here is, as humans do, whether we write on a Word document, whether we keep in our head, and hopefully we'll remember that when things are, you need to do it again. Um, these will be advisors. I think the key word here is this. We also call construction intelligent cloud an advisor. these will be advisors, kind of reminders to us about what potentially could happen.
So Shahir asked an interesting question, is that this is because this is globally offered, the question is, were the seed models created or are there versions of them that are also regional? Because obviously schedules will be really different in the US than they might be in, say, India or wherever else, or Australia.
I actually don't know the answer to that, so I need to check that and come back to you guys. It's a great question. I was thinking about it as we're going through it. I was thinking that I need to ask the same question too. I will come back. I need to find that out.
My not knowing the answer, but just as a thought, is you're going to be offering this where Aconex and Oracle have a strong business and have been around a while. So presumably there's some of that, but we'll for those that are interested, we'll find a way to follow up and let you know.
Yes, great question.
Awesome. So
Now,
now that we've talked about stuff that you can go buy, now we're going to talk about the fun stuff that is in the James Bond villain layer up in Chicago.
well, I wouldn't call that villain layer, but I would call this. So the things that we're going to talk about next is the technologies that we're working on, our teams are working on. So, and I will give a little bit of context and background. So, one other thing I want to highlight is we see the value of these technologies. We group them in three, not in isolation. Like the example on the safety, hey, it's machine learning, but it's also vision. It's using vision as a data input, right? So the value of it is significantly higher, and it's like 1 + 1 is actually more than 2 in this case, where when you have multiple of these technologies working together, bring so much more value. And the examples I'm going to give, especially on the Gen AI front, the prototypes, they're not using one technology. They're using multiple Oracle technologies to actually work together, from vector databases, from RAG to AI agents, from like multiple things, actually like ability to read things, ability to turn into text, reading, listening conversations. Again, it's not one thing. It is using multiple things. And we are seeing that trend more and more for especially industry use cases. That's where the value comes in. Now, let's talk about this one. So 3 years ago at the lab, and this is an image. I don't know how easy it is, but right little above, I want to say left, I want to say left side of those pipes, there is a blue drone that's actually flying and there's like a light. I don't know how well audience can see it. So what was this use case? In the manufacturing space, this is 3 years ago, we were having discussions about inventory management, automation. And one of the things customers kept bringing up is, hey, I would like to automate some of the inventory management processes. And what we have done is we have worked with our partner Skydio, which is that drone which can autonomously fly. It goes to a location, it takes an image. That image is saved to their cloud, then it pushes to Oracle Cloud, and we use Oracle's vision services, and it counts the pipes that you see here. Where does that data end? Then from there, the data goes to our ERP system for inventory management. Fast forward, look, last 12 months, and if you follow the news, you're going to see that like Amazon and IKEA and like many warehouse management, they're already doing this, right? We're talking about something we did 3 years ago. And 3 years ago was, is this doable? Is this achievable? The short answer was yes. You can automate in manufacturing where you use a drone, cloud, AI, 5G that kind of combine all this together. Can you automate data capture? In my mind, like a robot is like a flying robot, like that's it. Like whether you have a ground robot, a flying robot, and I think if I remember correctly, I think the IKEA example is drones that actually go up and down. There are like robots used which actually for retail where they scan, at the end of the day, they go to the aisles and they go around and scan what's actually in there. So that does inventory management. So this is becoming the norm now after 3 years. But this was our first test of trying to see how we can actually automate that process.
And if I could stick here for a sec, one
Yeah.
of the things that has always been cool about your labs, the whole point of it is to see how things work together for real products and real use cases. And one of the things that often happens when you talk certainly about AI, but really almost any technology, when it's all on its own, it can do some things. But in the real world, it's usually part of a suite of things In this case, you're dealing with a little bit of kind of a lower level of the stack where you're combining things. But everything in real use is multiple technologies or multiple products coming together to get something done. And I think a lot of what you're doing is at the front edge of, okay, what if we tried this plus that? How could we make it work? And to your point, 3 years ago, you were figuring something out that some of the big dogs have actually deployed since. But that's a really important thing to remember, I think, about AI is as we talk about its the probability and the accuracy and all that. A lot of what makes that useful is you've combined it into a process or combined it with other things that make it super useful, even though it's not 100%, because again, nothing is 100%. But it's
Yes.
the product that you use, not the core kind of technology.
And let me say this, one industry's innovation or, breakthrough actually becomes another industry standard. So like this starts in manufacturing. So I'm going to change the gears with, I'm going to show you the audience, something we developed a year later. And this is done by our utilities, energy, water business unit. Well, they've taken the same concept. I said, okay, we've seen what you've done, right? So it's manufacturing. You go take an image, it recognizes something and it pushes to an ERP system. They wanted to do the same. And what we have done is this steel structure that's inside the lab, by the way, that image that you see on the right is a decal. So it's not actually rust, just to be clear. So we actually did not make it, unstable. So we put an image of a rust and the same, if you think about it, it's the same workflow, but the endpoint is different. What this does is drone takes off, autonomously flies, takes an image, takes multiple images, and then it recognizes which one is rust and what probability it is. Like this will say, okay, it's 90% probable this is rust. And then it will send the data, and the data is location, like lat and long, and severity level. It actually looks at how severe that rust is. And I'm trying to location, severity level, and what the issue is, let's say rust. And it will actually send it to a work order management product, which is to tell the crews, go check this out. Like, here's an issue, we just captured it, and do that. One other thing happened is, so 3 years ago, I'm talking about the manufacturing use case. 2 years ago, I'm now talking about energy utilities use case, right? Reality is the Rust is applicable to everything if you think about it. Like it is also construction, it's also operations and maintenance, it's bridges, it's like everywhere. And what's very interesting is how some of the parts actually have improved. A good example is we've been working with Skydio, which is the drone that you see here for over 3 years. And their ability to autonomously fly has significantly improved in the last 3 years. It's kind of fascinating to see how it works. And that's another AI story, by the way. When I explain the audience how you actually train the flying robot to fly and then how it actually works. So you hit record, you have a controller like any drone pilot. You fly it. So you fly it, you go to one location, say click, take an image, you go to another, you fly. And then when you're done with your work, you actually click land. So it autonomously goes and lands itself. The key there is the drone then saves its data, which is it creates a whole map of the environment. It saves its data to its cloud. And then it optimizes the path. So let's say it took me 5 minutes to do this flight. Why? Because I went to a location, I lingered for like 30 seconds, take an image, I do this. Now, what it does is it optimizes the flight path on the cloud. Then it sends the new flight path to the drone. And when you do the mission, you say, okay, do the mission now. It's going to take 3 minutes. Why? Because it went from 5 to 3. And one of the things we have seen, again, as it's improving, we're able to compare how we collect data as humans to how the drone, full autonomy, can collect the data. When a drone flies, what typically humans do is you fly to the location and then you adjust your camera up or down or left, like you adjust your camera to look at something and take an image. What we have observed is because this is all pre-programmed and it optimized it and it knows where it's going next, it is kind of amazing to see as the drone is flying, it's actually adjusting its camera. So when it actually comes to the point, the camera is already adjusted. And it takes like less than a millisecond to take an image and goes to the next location. So this is showing you how, yes, vision is great, but how Skydio was able to learn how to optimize the path, even adjust like its camera while it's in flight, knowing where it's gonna come to and how it needs to actually collect that data. This is all talking about massive machine learning, right? We're talking about deep learning here. We're talking about vision here. We're talking about how autonomy is actually coming into our lives in terms of a flying robot. Now, take that, you can apply that to other robotic products. You can apply that to, we're hoping for autonomous vehicles, right, for a long time. And they still have issues with the edge use cases. That's why we're not, actively using them yet. But in the industrial use cases, there is a lot of autonomy coming in. I think that's the important one. As the process is automated, like the workflow I mentioned, I think we're also learning how to automate the collect information.
And to me, that's really exciting because, imagine how many things you wish you knew about a job site, but you'd never have the money to pay somebody to go find out. I think just we're not there yet in terms of really understanding how transformative that could be. You hear about things, this is a little more on the maintenance and operating side, but how many oil rigs or how many bridges or how many other things are on really, really long inspection cycles of like 18 months, 2 years, 5 years, whatever the number is. If you automated that and the cost was not won't be zero, but was very low, you could have much better information, both on the maintenance side and the operating side, in a way that it's an entirely new set of possibilities, both for construction but also for the things that we actually build later, and we'll see
Yeah.
where that goes.
Now I'm going to the third part of the story. Okay, so audience follow me. So we talked about manufacturing, inventory management. We count things and pushed it into an ERP system. The second, we talked about, okay, 2 years ago, the team worked on automating this for rust detection and then work into a work order management. So what are we doing today? So we actually built this little tower that you see on the left, and that tower actually has defects. I don't think you can see it from the image, but there is bolts that are not.
You got buckets stuck to it.
Yeah, buckets actually have targets like to collect data. Yes, buckets stuck to it, and like it has defects, it has rust. Like one of the things the team has done is they um, with a product unifier, so you can take pictures of these issues. So they were actually able to take images from a mobile app, you register, and it automatically classifies them of what it is. Okay, so you took the image, it will say it's bolt alignment, it is rust, it's this, right? In this model, what I'm talking about humans taking pictures. What we're looking at is, can a drone take pictures and we process that? Yes, why not? Can the robot that you see here, which is our partner Anybotics, and on the robot at the back of it, you see this gray thing that's actually a camera. Like there's a camera on it, there's light, there is a thermal camera and a sensor for sound, like it actually hears sound. So the circle thing at the front is that's the LiDAR. Actually, it's the back of it. So just to be clear, like that's the back of the robot, but back and front could be any direction for a robot like this. So LiDAR is used to navigate that circle thing that you see with the light on, and then you see this gray thing on top where it's the camera, all these sensors on it. So what we are proved is we can take an image, it goes to our vision services, and it can classify 7 things based on the exact same thing, probability. The team actually has shown me, actually it was 2 days ago, that they took an image. It actually had 2 issues. It had rust, and at the very top left corner, it has like a bolt issue. While it said, the vision said 90% probability of a rust, the bolt wasn't that clear, like it wasn't the focus of the image. It says like 45% issue with bolt alignment. So we were kind of pleasantly surprised that it didn't just recognize just Rust. It actually was able to, but like I said, the image wasn't focused on it. So it actually said it's 40%. So what we're learning is, as the next step is, hey, we can do this with just taking images and using Unifier. What can we do with automation? Can we automate that too? Going summarizing, tying all this together, I think this is a great example of you can start from manufacturing, go to utilities, energy, water. Now you're going to construction. And my experience actually, when it comes to automation, we're in the construction audience, so I'll be very honest with all of you. I think when it comes to autonomy and collection of data, it has been challenging for adoption in our industry. And if you follow the pattern, manufacturing is pretty much leading automation, right? So no surprise, our first trial of this was from manufacturing. And then I am personally seeing a huge uptick on automation in energy and utilities. Part the reason I think because they own their assets, right? So those things are also they own the assets, they're not moving anywhere. You can invest in them. And they also have, different challenges, especially the last couple of years, like, labor force trying to how to operate them, how to maintain them, security. There's a lot of use cases came up. Seeing more and more automation in the maintenance and operations of utilities. And now we're actually looking into construction, and that will tell you, that is based on the level of interest and adoption that we're following.
And obviously, the scale that utilities have to deal with is a little bit like civil construction, right? Where
Yes.
it's part of it is just how do we cover, 100 miles or more.
Yes. Yes. Any questions from the audience? Are we good so far? Okay. So I'm just checking time. I think we have like
We're
another
good. We
15.
got 15 minutes. Yep.
Okay, just to be. So we're in the third topic of Gen AI. So we have shared this almost a year ago, and our team is working on this.
And just for the audience, gosh, I'm sure people know this, but when we say generative AI, we're talking about things like the chatbots you're used to. There's image recognition, there's image creation, video creation, and all that. But kind of shifting gears from sort of classic AI, which was more deep learning, to things that are a little bit more like what you've seen over the last 2 years. Sorry, Virgin, go ahead.
Oh, great introduction. Thank you. So, what are we doing? When you work for a company, one of the key things is you receive RFPs, requests for proposals. And when you request for a proposal, typically you have a short timeline, a week, 2 weeks to put a budget together, put a schedule together, make a proposal of what that is. And what we have done is you go to, and in this case, it's called AI Assist. You go to a bot and then you say, hey, I received an RFP. You upload the RFP. And what does generative AI do pretty well? It does a really good job summarizing, right? So it summarizes the RFP for you. And then it picks certain data points. And then it asks you questions. It asks you questions like, what is the type of the structure? So let me tell you the end game. The end game is to build a baseline schedule. That's the end game. So you upload the RFP, it captures some data from the RFP, and then it's asking you questions. What are the challenges with this? Look, RFPs are inconsistent. If anyone works in the field, in the industry knows this, right? So not every information is in the RFP. So it needs to ask some questions. It asks you questions, and then it tries to fill in the gaps. What it does is then it automatically generates a baseline schedule. We have been working with some customers to actually, especially the last 12 months, to develop this. And one of the key things we have learned is, how does schedulers do this today? Well, when they receive a project, they just look for a similar project. It's like copy and paste. They take an older project, they adjust it. It could take a day, it could take more than that, depending on the complexity of the day, of the project. So the intention here is not to replace the schedulers, is to provide them a baseline schedule based on the parameters that's given, which actually will help them a starting point. What will be the improvement? Something will take you a day or two you could probably finish in 3 to 6 hours or so. Like basically, it is gonna take you, you know, ask some questions. Eventually, it is gonna generate you a baseline where you do not need to go back to an older schedule and start from scratch. So that's the difference. And why RFP? Because it is a very important part of business process, and timely response is very important. And by doing this, the intention here is we would automate the process so that it will provide a good baseline for the schedules that you start with.
Love it. Super exciting. Any questions from the audience? Cool.
Okay, so let's go to the next one. So, look, everybody, like you said, everybody's talking about the chatbot. It does these things. I'm going to switch. When I talk about the technology that is, for Oracle, is commercially available, which is AI agents. So it is one thing to go to a bot and say, what is the type of equipment is this? Which, if you go into the detail, you probably heard these terms as RAG, where you can direct the bot to a certain place to capture information. Actually, let me stop here and then kind of summarize how you can train or make a bot better with the industry data. So there are base models, right? Frontier models. One way is you can actually train that model with industry data. That's timely, expensive, and it's a massive task to do. You can also train it with some selective data, pre-train it. That's another way of doing it. Another way of doing it is you can tell, hey, go, here's my vector database, go look at this information and then pull this for me. Like you can ask a question, say, what type of equipment is this? When is the last time this transformer was, inspected? So what it does, it goes to a certain place, it looks for that information, and in plain English, it's going to actually provide you a response. And those use cases, it does a fairly good job. Okay, so like it's pretty accurate, it does a good job. And we put some guardrails around it to make sure it doesn't hallucinate. That's another topic, deep topic, but like it actually does a really good job. What I'm talking here is in that one, actually start using things called like AI agents, where you will be able to say, in this question, if you look here, it says, how many customers does this transformer serve? Are there any customers identified as critical? And the response is, this transformer serves 6 customers. Among them, 2 of them are identified as critical, Walmart and SOMC Medical Center. So this is a lot different question than just tell me what is my, what type of transformer it is. And to do that, you are actually using agents. You're explaining agents, you're providing recipes in this case to go and look at certain things in a certain manner. And then when the questions ask, the bot is actually making the choice of which recipe to execute and answer that question. So this is coming. It's already like Oracle has AI agents available. It's already coming. I think everybody in this field has been talking about this last 12 months. This is going to change how we interact with data. Also, there's a lot of potential for this for project management. Like imagine one day you'll be able to say, and I actually did try this. So I'm sharing from experience. I tried a year and a half ago, one of these systems. I said, hey, build me a 2-story, 50-spot sustainable parking garage. So I set the goal, and then it started building me tasks. It asked me questions. Hey, where is the location? And it said, I need to go check the zoning for it. And it says, here's my research. It went to internet and said, here's my research of all the sustainable ways you can actually build this. Which ones do you want to use? After a while, it stopped working, just to be clear. Right? This is a year and a half ago. And in this world, by the way, I'm sure audience appreciates this. Like even 3 months feels like 3 years. Like the speed of how these things move is insane with the investment and the resources, everything else. But this is, I think, a major change that's coming. And everything we do, it is going to impact us. I'm going to tie it to this use case. Hands-free AI assistant. Look, I think it's over a decade, 2 decades, we've been talking about doing things without touching, right? Talking, voice, hey, you can do voice ordering, you can do this, you can do that. So the energy water team actually built at the lab a prototype where it does field service. Everything is hands-free, but it's also using not just one technology. I want to say like 3, 4 different technologies when it comes to Gen AI. Like it's using OCI language, it's using I think it's called Smart Advisor, it's using OCI Gen AI services, like it's using multiple things. And the intention here is, yeah, like you are a worker, you climbed, as you see on a pole, you can ask the question, hey, what kind of equipment is this? It will go find it. When is the last time it was serviced? It will do that. You can take a picture and it will identify the picture. It will, can vision can do other things. We did not do that part, by the way. So there is like a lot of things we can now actually make that thing real rather than, hey, like today, a lot of the hands-free, you can say, you can speak and it will dictate and it will record it, right? So it will say that. You say, hey, this, my service was the blah, blah, blah. I was here in this location, and it's pretty much like, writes it for you and it actually saves it. The intention here is using techniques where we can further automate that process. And this is a utility example, but it's applicable to construction, it's applicable to manufacturing. This kind of everything ties together.
What's interesting about this, if I can just jump in, is what we are learning about chatbots is this technology is better at being interactive than just press a button, get a thing. So you could imagine this being a conversation because the system maybe can't quite tell what it's looking at. So it says, this looks to me like it's the X45 transformer. I'm making that up. You say, well, no, actually, I think it's this. Like you could imagine it becoming a conversation where it's like a hyper intelligent intern, and it's allowing you to still have control. And it because what drives people the most nuts, when you press a button, it does 5 steps and it got step number 3 wrong, so the whole thing is wrong, as opposed to being an interactive aid to you that allows the human to still be part of the process, and automating things where the probability is high, but still being useful when the probability isn't quite so high, because humans are often good at either moving the camera or kind of making that leap. Before we jump, I've got a question I want to ask.
Sure.
Does the generative schedule also identify conflicts and divergences in the RFP information and generate a potential risk of tender queries? It sounds like an awful lot. Identifying these disparities. So this is from the audience asking a pretty detailed question. Did you catch that?
I catch the question. I don't know the answer.
Okay.
I can find that out too. But it's a great question because yes, there's as someone I actually worked on for 5 years in pre-con, and I definitely know could be a lot of inconsistencies on the RFP documentation that you receive. And one of the things happens is, I'm sure the person who asked the question knows this really well, is when those inconsistencies come, you send, questions back to the owner. And then whoever sends the questions, let's say I send 5 questions, Hugh, you send 10 questions, owner takes those 15 and they actually issue all of us back. And by the way, this is human intelligence, not machine. I used to look at those 10 questions you asked. That will be the way I would figure out how you're actually putting your proposal together. Like,
Hmm.
sir, if you ask certain questions, I go like, oh, they're gonna do the podium this way. I guess that's why they're asking this question. Every builder will do things a little differently. So I think that's the process. I don't know the answer, but I will find out what level it goes in terms of assessing, what shall we call it? Like um, evaluate the accuracies of the RFP, and then if there's conflicts to figure out, what questions to be asked and, how to deal with that.
Excellent.
Now if we've got 4 minutes left, so we're really on time, on schedule. So that's great for, talking about construction and scheduling and all pieces. So what are we doing? We're really working on one Oracle for construction engineering, and the products on the left, which probably audience already knows, like Primavera, Unifier, Portfolio Management Scheduling, Aconex, Textura, they are construction engineering applications. They are widely used in the industry. And what we're doing is we are working on back of, so that's really a lot of the stuff is front of house, if you think about it. And many industries we work, we touch our customer's customer. Let me explain what that means in a little bit detail. So like we in the energy space, we sell products to utilities, which their customers engage with. Like we have a product that tells you, hey, you're using this much energy, you should do X, Y, Z. And if you think about construction, it's very unique. The products we sell is used by project managers to deliver projects, and it could be project management, by the way, not just construction. That's another thing I learned. If you're building a Navy ship, you use our products. If you're a spaceship, you do that too. Like you're doing production planning for a factory, you do that too. Like it's really engineering is really wide. These are the applications, and what we're doing is we're actually tying the back of house and the front of house. So the front of house is those things that the project managers use, they engage with and build things. In the back of house, like you see here, the human capital management, supply chain, all those things. And there's going to be the third-party apps and the data that comes in. So this is what we are working towards, is to actually have all these things tied together rather than them being in isolation. And sitting on top of our infrastructure. That should mention definitely that. And the bottom it says Oracle Cloud Infrastructure, because eventually everything that you see here sits on our cloud, runs on our infrastructure, and that's how it's managed. And
Well,
I
Bertrand,
think that's it.
we're at the end. Yeah, yeah. So
Yes.
I want to thank you for an amazing walk through all the stuff you guys are doing. Folks, we recorded this obviously, so we're going to post this on LinkedIn, and I will make sure to tag Bertrand there as well. So for some of you who've had some follow-up questions, at least one came kind of towards the end there. Feel free to reach out to him and his lab. This is just the tip of the iceberg. I joked before about the layer, but the point of it is it's a special place where they are able to bring together technologies and combine them in ways that no one else is doing yet. And obviously, in some cases, years before anyone else. So it's pretty exciting what you guys are up to, and I really appreciate you giving us a glimpse at how you're making AI work in the real world and also in the future. So thanks again, Bertrand. This has been great.
You're welcome. And one last point I want to make is I want to thank Oracle team. We work with a very large group of people in the organization, also outside the organization. I also, we couldn't do like the examples I've given some examples with partners, right? Antibiotics, Skydio, others. I want to thank the team internally at Oracle actually work on these, and also the partners. It's a team sport. Look, I been saying this for 5 years. Innovation is a team sport. It takes a lot of people, a lot of effort, a lot of vision to kind of pull all this together. So the team has been doing a fantastic job.
Awesome. Well, thanks again for being here.